Okay, so the previous podcasts had some sound issues, but I obviously am not going to re-record them. But what I did was buy a new headset. This is not as easy as one thinks when you do it at home. Yeah, I'm used to doing this in a studio with professionals, so this is a learning process. The naming convention also, I'm going to try to number them because it turns out Google decided you cannot change the name of the podcast once you upload onto YouTube. Okay, so just use the playlist to find the podcasts belonging to each chapter, then use the PDF files I provided on Facebook, and then follow the topic in sequence. Okay? Alright, so this is a very simple chapter on waves and water dynamics. Fairly straightforward. Everybody has been exposed to some form of waves somewhere in life, either by throwing a little stone in a pond and watch the waves emanate, or in a physics class with the tuning fork and so on. So in the ocean, almost all the waves are wind driven, but of course there are tsunamis, which is an important part of this chapter, and also there are waves generated by storms. Storms is a very generic term, but we will define wind speeds and the nomenclature that goes with those wind speeds. Waves are always moving energy, right? I think you have some sense that waves don't move mass, just the waveform moves, and we'll see what are the different waveforms. But waves always move energy. That's why they're important. There are deep water and surf zone waves that have very different characteristics. We will define shallow water waves, deep water waves, in addition to learning about tsunamis. In one of the later chapters, we'll learn about tides, also a form of waves. The forcing mechanisms are different, so that chapter is separated. Tsunamis are especially fast, and they are long waves, and we'll see what that means, and they are generated by seismic events as opposed to wind forcing and so on. Okay, so what is a wave? You need two things. One, if you have something, let's say on a table, and you push it, it's going to move, and it's not going to come back unless it's, let's say, attached to a spring, and the spring can pull it back, right? So if the spring is very nice and flexible, maybe when you push it and release it, the object will oscillate back and forth, right? So you need a disturbing force or a perturbation force, and for a wave to form you need a restoring force, and we'll see that most of the time the names are related to the restoring force that creates the oscillation. Okay, in the ocean you have winds blowing on the surface, so you have the interface of air, which is very light, and water, seawater, that's very heavy. So you have waves at the interface, air-ocean interface. These are what we typically call ocean waves. And there are waves in the atmosphere. There are also atmospheric tides, which we won't talk about. And there are atmospheric waves, as we mentioned in the previous chapter, generated by the heating released by condensation of water vapor in the atmosphere, and we said they can travel pretty far from like the Western Pacific all the way into the Arctic and into the Antarctic. Okay, and they can go around the globe. Okay, so there are water interface waves within the ocean, because there is stratification and there are density gradients. So you have interface between these different stratified layers of the ocean, which produce waves. We call them internal waves because they are in the interior of the ocean, and they can break and release energy, which causes mixing and causes the density of the water to change. For example, if you have stratification and isopycnal layers, which means constant density layers, the interface of the isopycnal layers can have internal waves, and when those waves break, let's say because of hitting a island or a coral reef or something, energy can be released and cause mixing. Those are the kind of things that we will look at a little bit more in this chapter. There are other waves, as I mentioned before, Rossby waves and Kelvin waves, which are caused by planetary scale restoration forces like gravity or Coriolis effect, which we will not get too much into in this basic course. Okay, that's the introduction. We'll start in the next podcast.